Hey folks, Professor Gray here, ready to talk to you about minimum sample size. Well, let's say you're conducting a study with the intention of estimating a population parameter with a specific level of confidence. In other words, you're going to do some research, and at the end you'd like to be able to make a confidence interval for the population parameter, maybe population proportion or population mean, and you want a particular level of confidence for this confidence interval. Well, before you ever start any research, then you need to pick a sample size at the very beginning that would guarantee you that you can make that confidence interval later on. You can't just pick any old sample size if that's your end goal. Now, the good news is there's a formula for this. If you're finding the minimum sample size to estimate a proportion, you can use this formula. N equals p hat times q hat times the critical value associated with the confidence level divided by the margin of error squared. And there are ceiling brackets on this formula. In other words, if you get an answer that is a whole number, then you leave it alone. If you get an answer that's not a whole number, round that up to the next whole number. After all, you're looking for the minimum sample size, so if you need at least that much, you're going to need a whole number because the sample will be comprised of things that are whole numbers. All right, if p hat is not known, then we let p hat be 50% or 0.5. That results in q hat being 50% or 0.5 as well, since q hat is 1 minus p hat. Let's do an example. You're a newly hired manager of a cell phone service company, and you want to determine the percentage of adults, or the proportion, in the state who live in a household with cell phones and no landlines. So they have a cell phone, no landline. And you want to be 90% confident that the sample percentage is within 4 percentage points of the population proportion. In other words, you want a 90% confidence interval, and your margin of error will be 4 percentage points because the word within tells you that the 4% is how much you are willing to be off by one way or the other. All right, well, what's the minimum number of adults you must survey? Well, for this, we'll use the formula on the previous slide. So we'll substitute what we know and solve for what we don't know. Well, the first thing to look at is p hat. Do I have a sample proportion or an estimate of the population proportion that I can work with? In this particular scenario, I do not. So I'm going to let p hat be 0.5. Well, q hat is 1 minus p hat, so 1 minus 0.5 is also 0.5. That's q hat. Those are substituted in. Now, z sub alpha over 2. We're interested in a 90% confidence level. So the critical value for a 90% confidence level is 1.645. And if I didn't remember that, I could look it up on the positive z-score page down at the bottom. Right-hand side in the margin, you have common critical values. 90% is a common one. Margin of error is E. We want the sample percentage within 4 percentage points. Within is a word that should send up a red flag. You're probably talking about the margin of error when you see a word like that. So 4%. Now change that percent to a decimal. That's very important. So 0.04 is my margin of error. Again, if I get a whole number, I'll leave it alone. If I get a decimal number, I'll round it up. As long as I use parentheses, I can type that in exactly as it is shown, all on one line. And I get this answer, 422.8 approximately. So I need at least 422.8 people in this survey, but I can't get 0.8 people. Thus, I will round that number up, and N will be 423. That's my answer and my minimum sample size. Now, a sample that's larger than that is even better. My end result will be more accurate if I have a larger sample size, but I need at least 423 people to guarantee the confidence interval that I want to make at the end. All right, well, number 25 has a very similar setup. Same idea. You're a manager of a cell phone company. You want to determine the percentage of adults who live in a household with cell phones and no landlines. 90% confidence level within 4 percentage points. But one thing has changed. Let's say you're reading a survey, a recent survey, and it suggests that about 8% of adults live in a household with cell phones and no landlines. Maybe you read it in a journal or a magazine. Okay, well now you have somewhere to maybe start off. So for number 25, we can change the formula just slightly. Again, here's the formula. When we go to put p hat in, now we have somewhere to start. 8% of adults live in a household with cell phones and no landlines, we think. Or we could treat that as p hat, our starting point. So 0.08 would be p hat. Q hat is 1 minus 0.08, that would be 0.92. Z sub alpha over 2, still 1.645 because we still want a 90% confidence interval. And the margin of error hasn't changed either. So all that is the same as it was. All right, so now, again, I can put that in my calculator as long as I use the parentheses pretty much exactly like it's written. And I get my answer. So N's going to be the ceiling of 124.48, we'll say. Well, if you need at least 124 people, or if you need at least 124.48 people, I should say, you can't have 0.48 people, but if you need at least that amount, then you're going to need to round up to 125. And that's your minimum sample size. More is great, but at least that many. Now notice how different these numbers are in 24 and 25. In number 25, we had a good idea of where to start, either from a sample or from maybe another study's suggestion. And because we knew where to start, our sample does not need to be as big as it would be if we didn't have any idea where to start. Either way, that's how you find the minimum sample size for a confidence interval involving a population proportion. Let's do another example. Let's say you're finding the minimum sample size to estimate a population mean. Well, here's the formula for that. N is the ceiling of z sub alpha over 2 times sigma, population standard deviation, divided by the margin of error squared. Again, if I get a whole number, I'll leave it alone. If I don't get a whole number, round it up to the next whole number. So here's the example. You're a researcher and you want to estimate the mean white blood cell count for adults in the U.S. in cells per microliter. You're planning on having a 99% confidence that the sample mean is within 0.2 cells per microliter of the population mean. Well, let's say that somehow we know that the population standard deviation is 2.5. Then what is the minimum sample size you'll need to make this confidence interval? We use our formula for that. We're finding the minimum sample size to estimate a mean. Now we'll substitute in. A 99% confidence level gives me the critical value 2.575. Again, that's a common critical value. All right, sigma is known to be 2.5. And the margin of error that I want is within 0.2 cells per microliter. So 0.2 is the margin of error. I can also type this in the calculator just as it is written, as long as I use my parentheses. Let me go back a little bit. There we are. And I get my answer. N is the ceiling of 1036.04. So I need at least 1036.04 people. Well, I can't have 0.04 samples, so I'll need to round up since I need at least that much. Round that up to the next whole number. You get 1037 as your sample size. So that's how you find the minimum sample size for a confidence interval for a proportion and a mean.